Hello and welcome. In the previous episode, we discussed Container Networking Interface, or CNI, and pod networking. We also discussed Flannel, CNI, in the context of Kubernetes in some details. We'll continue that trend, and today we'll discuss another popular CNI provider called Calico. We will gain detailed level understanding of how Calico works and how operationally it differs from Flannel. In case you missed my previous presentation on CNI, I'm going to discuss this in some overview in the next couple of screens. So basically, CNI is really an open source software that provides network plumbing for containers. As containers becomes popular, then it becomes evident that every software has to do the same thing to set up networking, assign IP addresses, and so on. And that becomes really tedious and repetitive. And this project basically provides a service to containers. So any software that deals with containers, such as Kubernetes, Cloud Foundry, Podman, and etc., can take advantage of the CNI interface that they provide. So let's see quickly and graphically how CNI works. So what I'm showing here is we have a server. This is a node, a Kubernetes node, and the entire thing is one server. And we have API Kubernetes services installed. And we also have a network namespace. So the network namespace really, anytime that you create a Linux host, it actually is also installed what is called a default network namespace. Network space is basically a container, and anything or everything just had anything to do with the network, such as the IP address, the interface, the Ethernet interface, the firewall rules, the routes, everything. So those are really contained in what is called a network namespace. So once we want to deploy a Kubernetes pod. So the API server calls into kubelet service. Kubelet service then calls into CNI plugin, and that's where it creates a pod network namespace like the one that we have here. Now the pod has its own namespace. Then it installs a virtual Ethernet interface that comes in pairs. So one side of the pair would be inside the namespace, and the other part is actually created and attached to the host. And that is a pipeline that provides communication between the host and the pod. It all then assigns an IP address to that pod. It also sets the default route, and that is how the communication with the outside world needs to go, what routes it will need to take. It also does the same thing on the host, and it adds the routes to the container. So now we have established a communication between the host and the container. Now that we have some understanding of how CNI plugins work, let's talk about Calico, which is a very popular CNI plugin provider. In the previous episode, we discussed Flannel. So to install Calico, once you set up your initial Kubernetes cluster, then you can run this command, kubectl apply -f, and this is the URL to where the installation package is. If you haven't done any Kubernetes deployment, no worries. I have a full course on installing Kubernetes on CentOS. I provide great detail information, including the scripts, so you can set your cluster up quickly if you follow that course. So Calico uses a dynamic subnet allocation scheme, which basically uses the Kubernetes API server etcd, or set up its own etcd if you want to do that way. So that basically has the reference of what APIs will need to assign to each node. And once Calico is installed, then it assigns a block of those IPs to each node, and each node is become then responsible for assigning the IPs to the pods that it creates inside it. The default encapsulation for Calico is IP in IP protocol, which basically involves wrapping a layer 3 IP packet inside an extra IP header. Let's see how that kind of really works. So this is an Ethernet frame, which consists of the MAC information, the MAC header, and the data, and the CRC checksum. So these are kind of routine. It has the MAC address of the server, the originating server, and this is the MAC address of the destination server. And then inside that, it creates a kind of other shell, an other layer of IP header, which really doesn't have anything in it, except it will wrap the actual data, which is again is an IP data. It has an IP, source IP, destination IP. So these are the source and IP address of the pod. So we're talking about pods here, and that's how it knows how to, so basically kind of this information piggybacks on the other layer IP, which has the IP address of the destination server pod. So the destination node that has the pod that we are reaching to. So again, you're talking about calling one pod from one server to another pod on a different server. If your pods are communicating on the same server, we don't need that. That's really only is used by default. Again, this scheme is used when we are communicating across nodes. So once this packet then is sent, it knows how to send that. It has everything that it needs, the MAC addresses, the IP addresses of the servers. And then once this frame gets to the destination server, it unpacks it, and then it knows where this, to which pod it needs to be sending it. So kind of hide this information, piggybacks it inside another IP header. And finally, Calico uses Border Protocol Gateway, or BGP, to share and exchange routes info between nodes. And that's how it facilitates pod network communication. To demo and explore how Calico works on a Kubernetes environment, I'll set up two servers. So I have a Kubernetes cluster. It has two nodes, the master node and node 1. And I have pre-installed a very simple Hello World application. It's got 4 pods. As you can see, there are 2 on each node. And as you can see, when CNI actually installs or configures the pod network, it also creates the vet part. So it comes in pair. One pair is installed, one part of the pair is installed on the Kubernetes itself, on the pod itself, and then the other part, the other part of the vet is actually installed on the server, so on the host. So as you can see, all of this 4 pods have 4 interfaces, have IP addresses, and each one of those, you can see the IP addresses, and also each vet has its counterpart on the server. So next, we'll go to the command line and kind of explore what, this is not a full story, of course. Calico has done a lot more, and we're going to explore other features of Calico. So I'll be using Visual Studio Code, and so we are inside Visual Studio Code, and I've already SSH into node 1. So as you saw in the previous diagram, we have 2 nodes. One is master and the other one node 1. So I'm running everything from node 1. So let's run the first command, IP ADDR, or give me all the interfaces on this. Basically, that's what it says. Give me all the interfaces on this machine. So as you can see, quite a number of them. It's got a loopback H0, so that is the default interface for the server itself. And then we see a number of other ones, such as Vibro and Docker. They're not being used by Calico, but Calico has a number of entries here. One is Calico and this GUI, and the other one is, so that is one of the virtual Ethernet that we saw in the previous diagram that connects the server to the pod, and this is the other one. So that on node 1 we have 2 pods. Each one of those has an interface that connects it to the pod. There's also tunnel 0, and it's got an IP address. Oh, by the way, these don't have any IP addresses because those are just basically these are the pipeline that connect to servers to connect the server to the pod. However, we also have what is called a tunnel, and as you can see, is something to do with IP. We'll discuss that later, but keep in mind that this Calico also creates this interface called tunnel 0, and it has an IP address. Okay, so that's as far as interface is concerned. Now, the next command, IP link show type vet. So I'm just going to verify again to see how many virtual Ethernet interfaces created. And again, no surprise, we have 2 of them. These are the ones that we show up here. So they're kind of verifying that we have the same one showing up when we run that command. Okay, we can also do IP link show type IP. So we want to verify this guy. We can also do that independently. So if you run that, we'll see that it shows as a tunnel 0 and then IP. So this is as far as the tunnel that we'll discuss a little bit later, and the vet for our pods. Now let's do a kubectl get pods -oy. They want just kind of display all the pods that we have. And again, this is very similar to what I'll show you in that diagram before, page before. So there are 4 pods that I installed as part of one Hello World application. As you can see, 2 of them are running on node 1, and the other 2 are running on master. Okay, so far so good. Now let's see how to get to one of those. So IP route get and the IP address. So basically I'm saying I want to go to this pod, 172.16.4.94.5. That is this guy. So if I want to go from node 1, where I am, I want to go to that, hit that pod. What are the routes that I need to go through? And this is the results, which tells me in order to go hit that pod from the server itself, from the node itself, you have to go through that interface. Again, this is the interface of the vet that connects the server to the pod. So again, that's what we show up here, this guy here. So in order to any communication that hits that pod, will need to go through that interface. If we do the same thing for the next pod, 06, this guy here, run that. Again, very similarly, in order to go from pod 1, I'm sorry, from node 1, hit that pod, we need to go to this interface, again, that we saw earlier. So there are no bridges here. Every time that you install a pod, a pod is installed on a server, Calico creates a route for it. Now let's say we want to hit a different pod. This one, 06, is actually on a different server on master. So how do we get there? So we run that. We'll see that in order to hit 206, we need to go through the IP of 192.168.40. That is master, so it's on the other server. However, we need to go through the tunnel 0, and with the IP address 172.16.94.0. And that was the tunnel that we saw up here. So we need to go through that tunnel. So that tunnel does the magic. So that tunnel basically facilitates the communication between pods on one server and pods on the other server. Now let's, next we'll kind of show you graphically what we discovered from this demo right now. So here's a view of our environment again, Kubernetes environment. We have 2 servers and then the 4 pods that we saw earlier. And as we saw, any communication that on the same server goes to any of these pods, it has to go through the vet piece on the server side. So again, these are connected together. The interface on the pod is really a kind of one side of the same pair. So you have a pair here and pair here, and that's how it's connected. So all communication from the same server going to the pod goes through these interfaces. It doesn't matter where they are. However, if this one pod wants to communicate with another pod on a different server, then as we saw, it has to go through the tunnel. And the tunnel, this is where the IP in IP transformation occurs. That is, it creates an IP header and then encapsulate everything in the IP part of this communication inside that IP. And then it uses its IP address as the source, so it kind of masquerades this IP address and then sends it through this interface of the node, and then it goes to the other node, and then over here, it disassembles this that IP information and unpacks everything, and then sends the information directly to that pod. And so this is kind of overview. Next, we are going to kind of explore what happens as the information is sent between you and how IP and in IP and the whole encapsulation works. We'll do that next. In this part of the demo, we are going to capture some network traffic and see how IP and IP works in action. So first thing, let's just run this command, kubectl get services, to see what services we have available for use. And I have this hello world that we are going to use for this demo. It's a very simple application. As you can see, the type is node port. That is, we can actually get to that service from outside the cluster. That is the cluster IP. And this is the node port, port number. So if we do curl HTTP and using the IP address of one of the services and the node port IP, then we will be able to call that service. And we can see the result, hello world, version number, and host name. So very simple application indeed. So let's again take a look at the pods that we have. And as you recall, we have 4 pods, 2 on each node, and these are pod names. The IP addresses are here, and those are the nodes. So we have 4 different pods, 2 on each node. So we're going to SH into one of the nodes, pods. So we're going to SH to this guy. Let's do that. And then from here, we're going to call a service on the other node. So one pod on one node is going to make a service call to a different pod on a different server. So we're going across the server and to see what's happening. So before running that curl command, let's go ahead and start our capture. So I'm using T-Shark. This is the command line version of Wireshark. So T-Shark minus I, that is what interface we're going to listen on. H0, that is the interface, the default interface on node 1. So we're running from node 1. Minus V means make it verbose, print all information. Minus Y, HTTP, we are telling Wireshark we are interested in HTTP. So please listen for HTTP traffic. So the nice thing about Wireshark, T-Shark is it understands HTTP. So let's run that. So that is ready for us. So over here, we're going to run that command, that curl, and again, we can see the results coming back exactly the same way. And over here, we'll see that it captures a lot of stuff. So let's scroll up here and see what's going on. So the capture started from here. The first part is the frame. So as you can, if you recall, the frame, the Ethernet frame contains everything. So that's the kind of exterior, the kind of outer part of the whole traffic. Then inside that, we'll see that we have Internet protocol IP, and then we'll see the source of our server, which is we are going from node 1, which is the 192.168.0.41, and the destination is 192.168.0.4. So this is the exterior, this is the IP header that it creates and then puts everything inside. So that's the kind of outer shell IP. And within that, we'll see there is another, and as you can see here, it says protocol IP. So the first IP header is of the type IP protocol. And inside that is actually the IP header, but this is the IP header of actual communication that one pod is trying to send to the other. The source for this is 172.168.194.0, if you recall. That is the IP address of the tunnel. So the tunnel on node 1 is actually masquerading the IP address of the pod itself. So and then the destination is 206. So this is the service that we are going to be calling on 192.168.60. So again, that's the IP address, the destination IP address. And within that, we'll see that, let's just scroll down. This is the TCP part. As you know, HTTP is TCP, basically. And then the destination port is 8080. That's exactly what we are calling. And then there are some handshake going on here. And then a little bit later, it starts packaging, kind of getting everything together. And it starts creating the Ethernet. So this is going reverse. Now we're going from the master. That's what the service was on. The service starts responding and starts creating the Ethernet. So that's the Ethernet frame. And then inside that, again, it creates another Ethernet frame header. Again, the destination now is reverses. The source would be 40. We're going from the second server back to our server where we started everything else. And then as you can see, it's exactly the same. So it kind of reverse, fast packets everything, all the information, and sends it back to the server, to the caller, to the pod that was calling it. And this is the package, the information that is sending it back again is exactly as hello world version. So this is how IP in IP happens. It's kind of like magic. It's very simple and very powerful, especially if servers are on different, like they're not maybe a different subnet. So that makes it things very easy to manage. So that is the demo for the default when we install Calico and we use its default IP in IP encapsulation. So hopefully by now you have some understanding of how CNI providers work, and also you have some understanding of how Calico using the default settings work. But there is a lot more into Calico, and we don't have to discuss everything in this session, but I'm going to talk about a couple of things here. First, we will just explore how Calico shares route information amongst its nodes. You're going to talk about a protocol called Border Gateway Protocol, or BGP, and that is something that Calico leverages in order for it to share routing information between nodes. And then following that, we will discuss non-IP and IP routing. So IP and IP is the default mode, and that is something that we all examples up to this point, we've been using IP and IP. So if you don't make any changes into Calico settings when you install it, by default, it uses IP and IP. It has some overhead, but it's not much, but still there is an overhead. So if there are situations that you don't really need IP and IP, and we go through some of those situations, it's better to actually not use any encapsulation. That makes it actually faster. And we call it direct. There's also another option for VXLAN. If there are situations which you can't use direct communication, or you can't use IP and IP routing, then VXLAN is another option. It's kind of similar to Flannel that we've discussed in the previous presentation. BGP is a standardized exterior gateway protocol, which is designed to exchange routing and reachability information among autonomous systems on the internet. So internet is run by BGP. BGP has really two functions, kind of overview. One is who on the internet I can send packet to. I, in this case, means a router. So a router then will know who on the internet I can send the packet to. And the second is make a decision which route should the packet take. So let's this is a very general overview of what BGP is. Obviously in depth, this is a very complicated system, but just for our understanding in the context of Kubernetes and Calico. So let's say there are 4 networks that they are not connected together yet through BGP, and each network only knows about its own route. So A only knows about A, C only knows about C, and so on. And let's say administrators in these 2 networks configure their systems to then communicate with each other as far as through BGP. And as you can see then, B update is routing information, because now by just connecting to the A, it knows that how to get to network A, and there's only one route between itself and A. The same thing, A knows about B now that they kind of handshake, did a handshake here. And so then let's say A and C are connected, set up to communicate with each other through BGP. The same thing here, C knows about A, and the number of hops is 1. And again, same thing between C and D, and now again, and so on. So now we have these 4 networks that know a little bit about each other, but periodically, they also exchange information. For instance, network A can share information with network B, and tells B, these are the routes that I know about. So when it does that, then network B take a look at it and say, hey, interesting. Well, of course I know about myself, and I already connected with you, so I know about you, but I did not know how to get to C. Now I know, so it updates its routing table here, and now it knows how to get C to C. So in order to get to C, it has to go through A, and the number of hops is 2. So B to C goes to A and then C. And B also shares the same information with D, and then D also now updates its information. Now D knows how to get to A, it needs to go through B, and the number of hops is 2. And finally, after all this handshake is done, then every kind of network knows about at least how to get to other networks. So this is the essence of how BGP works. And Calico takes advantage of this protocol in order to share routes among its nodes. Now let's see how Calico actually leverages BGP. When we install Calico, by default, it creates a full mesh of internal BGP connections. And the way it does it, it peers every node with every other node. And that's how we have a full mesh. So any route changes happening on one node, that is reflected immediately in every other node. So they will be aware of that. If we have a L2 network, that is, if we have all our network on the same sub, and we have all our servers, Kubernetes endpoints, nodes on the same subnet, then Calico can leverage L2. Otherwise, if we have maybe some of our servers on a different node, on a different subnet, then we can configure to use IP and IP instead. As long as IP and IP traffic is not blocked, then full mesh can be established using layer 3 network. Note that if we choose to use VXLAN instead, BGP is not supported in that scenario. Now let's say we have Kubernetes cluster, we have 4 nodes, as you can see here. The next step for us would be to install Calico, and that is how we install Calico. When we run that, Calico starts installing some software, and kind of can think of it as installing a virtual router on each of the node. And then that becomes really, each node becomes an independent network, and then establishes full mesh. That is, every node is paired directly with every other node, and that is how the full mesh is realized. And this really works great, and it is really fast if we have maybe not too many Kubernetes nodes. But if we start having, our networks become bigger, and demand for our network or Kubernetes cluster becomes bigger, maybe we add a lot more nodes. And as you can see, in the long run, this kind of full mesh is not going to work out. So fortunately, Calico supports route reflectors. Basically, what it means is we can select a few number of nodes and then establish full mesh among those nodes, and then have other nodes peer with those nodes. And that, if there then any changes that happens in a sub BGP, let's say this node has a number of nodes that are connected to it, then any changes in any of those nodes, any route information, it sends to this node A, and then that's node A, and then it also reflects as changes, sends changes to the nodes that are directly paired with it inside that group, and then start doing the same thing with other leaders of the nodes. And then over time, those changes are reflected, and then any changes that happens in one node, as far as routes are concerned, are reflected in other nodes. And that really works great in a larger Kubernetes cluster. If we set up Kubernetes on our premise, on our cloud, maybe internal cloud, we have full control. We can configure Calico to peer directly with our physical network infrastructure. What it means really, typically, we disable Calico's full mesh, default full mesh behavior, and instead we peer Calico with our L3 top of the rack router. So we have a number of options. If we have a small network, then we can use full mesh as is. As it grows, we can then choose to have route reflectors. And the best option is if we have full control over our environment and we have a hardware that supports top of the rack, then we can actually configure our network to use top of the rack and set up mesh full BGP in that way. So in the previous two slides, we saw how BGP works in general, and we saw how Calico implements BGP as a full mesh by default. Now let's dig a little bit deeper into what happens actually when we set up Calico and what processes are involved and what services are involved. Let's say we have our cluster again. We have two servers and consisting of our cluster, and we are using, say, IP in IP as a default encapsulation method. And as you can see, each node has its own network namespace, has a default a network adapter with an IP address on each side. There's also, because you're using IP and IP, there's a tunnel that is set up on each node. I haven't shown this over here, I'm just showing it over here. So, but there'll be a tunnel over here as well. So any communication that happens across the service between services and pods go across the nodes, it goes through a tunnel. Let's say what happens when we install a service which has deploys a single pod. So as we saw earlier, what happens is the API server calls into Kubelet. Kubelet calls into CNI plugin. The plugin creates the pod network namespace. And then it creates the VETs, that is a virtual Ethernet on both sides. So we have one side which has an IP address, the other side is not. It's just basically a pipe that connects these two, and also sets the default route for the new pod. Next thing that it does, it calls into a daemon called Felix that is installed by Calico. When we install Calico, its primary role is to manage the routes. So now that we have a new route, it actually programs the route table, and it adds the IP address, the destination of this pod, and how do we get to that. In order to get to that pod, because it's on the same server, we just simply go through this Calico interface here. So that's what it does. And the next thing that it does, it calls a service called BIRD. This is basically a BGP agent, and that BGP agent passes that information. The route that just we created, it passed through the BGP agent from one node. It talks to the BGP agent or BIRD on the other node. It also then talks to its own Felix, passes the information about the new route. And then the Felix on the second node also programs its route table. The destination again is the same. However, because this is going through across the nodes, you'll see that it goes through the tunnel 0. So any communication that is destined for this IP address, for this pod, will need to go through tunnel 0. So in summary, when you install Calico, it installs two important daemons. One is called Felix, that manages and programs the route table. And then the BIRD, which is the BGP agent, and that's how the different nodes talk to each other. The BGP agents talk to each other, and that's how when a new route is added on one node, is reflected on every other node. So the last thing I wanted to talk about was Calico networking options. So far in our sample cluster, we had two nodes, and we have been using IP and IP overlay network. And that may not be the best option in our prem. Is actually not the best option at all. So we'll talk about some other options that provide better performance. First one is non-overlay network. And this is the most performant option, as there is no encapsulation and decapsulation, because that will take CPU time in order to do that. We have a couple of options. If we have control over our hardware and our hardware supports top of rack, then we can simply use BGP to peer with top of rack routers. And the benefit of this, first of all, there's no encapsulation. And the second benefit that we get is that our IP, pod IPs will be routable from outside the cluster. So that's very nice. If that's not possible, but we have all our nodes on the same subnet, L2 subnet, then we can simply use Calico for BGP peering, among nodes, and then basically use it that way. In that case, we will not be using any encapsulation, although we are not those pod IPs will not be routable from outside the cluster. That's the only disadvantage of that. But other than that, it gives you the performance of the first option. If we are in a situation where we have our nodes on multiple subnets, then there's another option called cross subnet overlay. And basically, the way it works is among it configures in a way that for the nodes that are on the same subnet, it won't use any encapsulation. However, if you are crossing, going, you call it one pod is calling a service on a different node, which is on a different subnet, then you can configure Calico to either use IP in IP or VXLAN as we cross the boundary. So that's a really good option to get the best of both worlds. One is you get the benefit of no overlay if you're on the same L2 network, and also it provides overlay if for the situations where we are crossing the subnet. And the last one, of course, is using a full overlay network, and that's what we've been using up to this point. And this is a situation where none of this is possible. So we can use either IP and IP, which I've used for this demo, or we can use VXLAN. So that's kind of up to you. So these are the options as far as the on-prem is concerned. These are very similar. If you're running, if you decide to run your cluster on either Azure or Google or Amazon, mostly the same things apply, although there are some differences. For instance, it's going to be aware of. If you're running in Azure, for instance, Azure does not support IP and IP. So if you are in a situation in which you can't use non-overlay within Azure, and you have to use overlay, then you have to use VXLAN. Also, there are some differences between them. So if you are running in the cloud, then I encourage you to read the documentation, Calico documentation. I'll provide the link in the description. Next, I'll show you how to make these configuration changes. Obviously, ideally, you want to make the decision before you set up your cluster, because you don't want to make these fundamental changes as you have clients and your workload running on it. So I'll show you next. So in order to change the network setting, Calico network setting after it's installed, we need to install a command line CLI called Calico CTL. I'll put a link in the description so you guys can go ahead and install it yourself if you want to interact with Calico and learn more about how it works. So the first command, we're going to look at the Calico node status. So let's run that. I'll put in my password. And this shows us the BGP status of our cluster. So right now, this is the peer address. So I'm looking at I'm running these commands on the master node, and I have only one more node. So you'll see that this is the other node. So we are looking at what server we are peering with, and that's the other node, that is node 1. And peer type is node to node and is mesh. So this is the default behavior. And status is up, which is a good thing, and already established. So this is how you get the status of your BGP once you install Calico. If you want to see if everything is running correctly and the peers are interacting with each other and it's up, then just run the command sudo calico node status. So in order to make changes to our network setting, first we need to look at what's called IP pool. So let's run that command. And so in Calico, you can set multiple IP pools. By default, there's only one. So this is the pool that all the pods on all nodes get their IP addresses from. So this is the complete IPs. So it's 172.16.000-16. So this is where obviously each node gets its own block. So it kind of creates subnets within this full range of IPs. And so everything starts with 172.16. And then on one node is, I believe, 16, on the other 94. So, but everything starts with 172.16. And that's how the pods get their IP addresses from. Now we need to actually download this file. So Calico CTL get IP pool, and this is the name of the file that we need to get, IP default-IP v4 pool. And then I'm just downloading it inside a YAML file, so we can modify that. So let's go ahead and run that, and that's done. Now we can open that in Nano and take a look at the file and modify that. So this is the setting. So let's just go through that quickly. Again, the kind is IP pool, IP, and then the create time. And so this is a metadata information, and this is the name of the file I've just opened. So, and then some information. So this is the block size. It's 26. And the CIDR, as we looked at, is 172.16.00. Again, same information that we saw. And this is the important part. So it says IP mode always. So this is, by default, this is, if we just download the YAML file from Calico and install Calico, by default, it says to always. And then at the bottom, you'll see that VXLAN mode is never, because we are not using VXLAN. So let's go ahead and make a change here, and in order to make Calico not to use IP in IP, all we need to do is just make a change here and change this to never. Oops. I should be looking where I'm typing. So make a change here. Never. So that's all the change that we need to make. And if we remember that if we are in a situation where we have some nodes on one subnet and others on the other, then we need to use cross mode. But right now we just want to say we don't want to use IP mode, IP and IP mode. So that's what the only change that we need to make here is just set that to never. Okay, let's go ahead and save that. Okay, and then all we need to do is then run Calico apply, next line, number 9, apply -f, and the YAML file we just created. So before doing that, let's go ahead and take a look at the route. So I'm going to run watch route -n. So this shows the current route. And pay attention here on this line where we are going across. We're going across from one node to the other. We have a pod that's making a service call from one node to the other. If you remember, we're going through the tunnel because we're using IP and IP mode. So if we now go ahead and run this, just make sure, and then we'll see how the route changes here for this line. So let's go ahead and run that. And then you'll see the change. Now it changed from the tunnel into eth0. So it's actually everything now is going through the regular interface. So you're not going through the tunnel. And that's the change that we just made So we made that from IP and IP to regular, because the reason for this, because both these servers are on the same subnet. So there is no reason for us to be using the IP and IP. So make this a lot faster. So we are in a situation where we have all your servers running on the same subnet, then you can go ahead and change that from IP into direct, basically. So you say we're not going through IP and IP mode. So now let's verify that we don't see IP and IP at all in the packet. So we're going to do another packet capturing, and then we'll verify that we don't see IP and IP. So I'm here in the Visual Studio command line. So let's go ahead and take a look at the pods again and see. So we have 4 pods, if you recall. We have 2 of them running on master, this guy and this guy. And these 2 in between, they're running on node 1. So I'm going to go inside, SH inside one of these pods on the master node. So I'm going to SH in here, and then I'm going to call a service, which is on the other node. So, and then we can then capture the packets and see how it's going. Let's go ahead and let's SH into that. Okay, and before running, calling the service, let's go ahead and run the capture command. And let's go ahead and now call this service. And as you can see, the packets have been captured. Let's go ahead and let me exit out of that and then maximize this. Let's go ahead up and verify the package from the beginning and do a kind of comparison like we had before. So again, the packets always include the internet packet, which includes everything, its IP and other information inside that. So this is the Ethernet frame. So nothing is shared there as before. However, in here, we'll see that now the source is the server itself calling into, so going from the server, because we're going through the regular interface. So this service called directly into the IP address of the pod. Previously, the other IP packet, had the source as one server calling the other server. And then inside that, if you recall, we saw there was an IP and IP. But that doesn't exist anymore. So this is actually, there's only one Ethernet packet, and everything else, there's no IP and IP anymore. And then the next step is basically the TCP. So there's no IP and IP packet that we saw previously in the previous capture. We'll see it doesn't exist anymore because we are not using IP and IP anymore. So basically, this is regular IP, and then this is a destination of the pod that we are calling, the service that we are calling. So that's it. So I hope you enjoyed this presentation. I'm going to summarize next, and then we go from there. So in this video, we covered the following topics. We started with we took a look at container network interface. I covered this extensively in my first and second series of this course. So if you want more information, go ahead and check those. We also introduced Project Calico, which is a CNI. It's one of the choices that you can make as far as selecting a CNI provider for your project. We looked at IP and IP protocol, what it is, and how Calico uses it. We learned about border gateway protocol, which is an important topic in when you use Calico and how it's being leveraged in Calico. We also discussed various network choices and when to use which. We also learned how to make a network change after Calico is installed. And the last thing, thank you so much for your time. If you like it, please give it a like. And consider subscribing. I have the other courses that you might be interested, especially in networking. I have 2 more courses. I'll include these courses names and link in the description below. So again, thank you so much, and please take care.